All right, so what can I fill in there for sure? Do I know anything for sure?
Yeah, Manly's 1 hour more than...
Yeah, Manly's 20 miles from town, and Caledonia is 15 miles from town, which makes sense that it takes Manly longer to get to town then, right? So just kind of, as you're doing the problem, make sure it makes physical sense. I can tell you so you put something in the wrong place. The speeds are equal, so it kind of feels like that problem. Whatever I end up with in these boxes is going to be where my equation comes from. I'm going to set them equal to each other, just like I did over there. So what can I put in here for the time? Manly takes 1 hour more than Caledonia. So whose time is just X? Caledonia, or T, or whatever letter you want to use. Caledonia, she takes X hours. Manly takes 1 hour more. Kick ass. Now what's a little evil is, if they would have said 15 minutes more, you can't just say X plus 15, because now it's taking them 15 hours more, and you're like, what are you doing? It'd be X plus 1/4, because 15 is 1/4 of an hour. Right? So be happy they didn't say it. So what do I put here? The same way we did over there. How do I get rate if I know distance and time? Yeah. So distance over time would be 20 over X plus 1. 15 over X. And then set those equal to each other, yeah. And then you cross multiply.
Is that what equal to?
What's got to be the same? The speeds are the same, right? So that speed must equal that speed.
So 20 over X plus 1 equals...
So you're with me up here, right? They tell me the speeds are the same. So that's Manly speed, isn't it? The other name for rate, when I'm talking about cars moving around, is speed. And this is Caledonia speed, so those speeds have to be equal to each other. So it's kind of nice, the chart's kind of nice because it helps me organize all the stuff they tell me. I try to get 2 empty boxes and then I fill them in using the dirt formula. And my equation comes from, is it the same? Did it take this one 3 hours more than that one? Then that minus that is 3. My equation is going to come from that relationship at the end. Here you just cross multiply, you can solve it pretty quick. Yeah.
Then what do you do when you find X?
Then you go back and what would X mean? X would be the time it took Caledonia. You see, setting this up helps you interpret the answer. If you get X, that's what it is. Well, what's Manly's time?
X plus 1.
Whatever X is, add 1 to
Plug
it.
it in.
Yeah.
And if you get a fraction?
What's mine?
And what if you get a fraction?
Okay. So then if you got like 5/8, then that would be 5/8. And this would be 5/8 plus 1. 5/8 plus 8/8 is 13/8. I mean, you can handle fractions. Fractions are not evil. Fractions are necessary. Right? Getting a fraction doesn't automatically mean you did a mistake. Right? Be careful about that. They're going to show up. Let's see. 30 is really very similar to what we already did from that section. Let's see. Whew, give me a lot of questions. Let's see, 10-1, number 11, yeah, that does get a little freaky. 10-1, number 11. So what they do here is they give you these 2 graphs. It almost really doesn't matter. So here's F, and here's G. And the question is, they want you to solve graphically. So when you first see this, you're like, what the hell do they want me to do? So they're asking you, when is f of x greater than or equal to g of x? So for a function to be bigger than another function, visually what must happen? So for a function to be bigger than the other function, what must be true? The bigger function must be above the smaller one. Does that make sense? It's just the same way as a bigger building is above a smaller building. Same idea. So where is f the bigger function? Where are they equal each other? Yeah, right there. So from 2, and actually I don't know which way, let's figure out. And after 2, what's on top? After 2, for 3 and 4 and all the other x's, f is on top, right? Below 2, g is bigger. So to answer the question then, it would be from 2
To infinity.
to infinity, exactly, because f would be bigger than, right? That's when f is above the other two. That's when the outputs are bigger than g's outputs. So the answer to an equation is always related to x. Right? For anybody curious about why I'm not looking at the y-axis, I want to know what x values make this true. So when are the outputs for f bigger than the outputs for g? From 2 to infinity. That's when f's outputs are bigger. Does that make sense? How to see that? How to look at that problem visually with the graph? You doing all right? All right. Take that as a yes. Let's see. Oh yeah, 30 I definitely want to talk about. Yeah, let me turn this dude on in case there's more questions about the graphing calculator. All right.
For 2.3 number 12, you just explained it already, so you don't have to go over it. 10.3.
Oh yeah.
Just,
Okay. 65. Oh, okay. This is a little bit freaky. This is 10.2, number 65. This one's weird, because it just looks like it should be really easy, but then people don't give me the complete answer. There's a few different ways to do this. You can attack it using the cases. How do I do absolute value greater than? What are my two cases?
2 greater than 0.
T greater than 0, or
T less than.
t less than negative 0, which is 0. So what's the only thing that leaves out? 0. What's the only time an absolute value is not bigger than 0? Is when the thing inside is 0. So it kind of makes sense. The only thing we leave out is 0. So what's t greater than 0 would look like this. T less than 0 would look like this. So that is just leaving out 0. How would I write that interval notation?
0, 0. No, negative
Infinity.
or
Infinity.
0 to
Or, yeah, this means skip, right? Skip 0 and go to infinity. Kick ass. Cool. I like it. All right. Let's see. Let me open it up to everybody. I'm going to give out the answer key here in a minute. If there's not that many questions, I'll give this sucker out. We'll try some of this stuff out here. Yeah.
I got a question from 10.4. It's 7 minus x squared is greater than or equal to 3.
Which number is it?
It's not in that, but it's online.
All right. And it says 7 minus x squared.
Is greater than or equal to 3.
And is it like number? I mean, what's the number on the problem? Because it's roughly the same as the book. 60. Okay. All right. So it's not there. So it says what now? It says 7 minus.
X squared
Yeah.
is greater than or equal to 3.
Oh, okay. So how is this different from the problems you were doing before for the section 10.4? What was the big point about 10.4? What did it have to be related to? 0. And it currently is not, right? So what can I do to make it related to 0? Yeah, subtract 3. So you get 4 minus x squared greater than or equal to 0. And what can I do with 4 minus x squared? Yeah, you can factor it. Yeah. So now it looks just like the problems we were doing earlier, right? Cool. So it's all about getting it in the right form first. So it's got to be related to 0. I like it. Yes, ma'am.
What about like when they give you the graph of it and then want you to determine the solution of the inequality given the graph?
Gotcha. So let's see. Let's do this. Let's see if this guy stays on. So while that guy's warming up, anybody else have a question? Yeah.
Oh, never mind, sorry.
Cool.
9.4, can you do 45?
10-4?
9.4.
9-4. 45? Oh, okay, yeah. This guy's still warming up. Let's do 45 and then, oh, there it is. Well, let's do this first. So then I'll do 9, 4, 45. So the question from over here was in 10, 4, like number 9 and 10 and stuff like that, right? Who asked that question? Did you ask that question?
Yeah.
Switch this guy. All right. Zoom. So let's look at number 11 since it just happens to be there. All right. You guys can see that, right? It's not too bad, the glare.
What section is it?
10-4. So this is very similar to this. So what this is asking is, what they've done is they graphed what x minus 1 over x plus 2 looks like. That's what that would look like. And there's an asymptote here, of course, because at negative 2, that thing would be undefined. So what undefined really means visually is negative infinity or positive infinity, right? And you'll investigate the hell out of that in pre-calculus. You're doing a lot of asymptotes and stuff. So what they did was they graphed for me what x minus 1 over x plus 2 looks like. And what else did they put on here? Well, does it make sense? What else did they put on here? Well, they put the function. And what else did they put up there? 3. So why did they put 3? Why did they draw this line through 3? Yeah, because it's less than 3. So now the question is, what x values make that true? So I can solve this kind of thing graphically, just like I can solve a system of equations graphically by graphing the lines and seeing where they meet. Right? Algebraically, I want to do it because sometimes it's a weird-ass answer. But here, the numbers are nice. What x values makes this graph less than 3? Or where's the only place it's bigger than 3? You guys can do this. When does this graph go above 3? Yeah, starting at this point. What is this point?
About
Negative 7 halves. And up to negative 2. It's above 3. So when is it less than 3? When it's here, right? So it's from negative 7 halves down, so negative infinity up to negative 7 halves. So what this question is asking is, when is this function less than 3? When are the outputs less than 3? Well, the outputs are less than 3 here, and they're less than 3 here, right? So it's less than 3 from negative infinity up to negative 7 halves. Or no, in here it's bigger than 3. Shit, I gotta throw that out. So where do I start over again? I start over again at negative 2. What am I going to put on the negative 2? Parenthesis, because it's undefined in negative 2, right? So it's going to look like this. The people at home are like, what's happening? There you go, people at home. Let's see. So now I can't see this. Too bad. So it's going to be from negative infinity up to negative 7/2. Why is that part of the answer? Because that's where it's less than 3. And it's also less than 3 starting at negative 2 to infinity. Good. We try to make this look like it's definitely going to be below there forever after. I like it. But it's always a little weird when they ask you to do something visually because you're not used to solving stuff visually. But I like it because it's another way to look at the problems we're doing algebraically.
Can you do the one before that, the one with the like squiggly graph? That's the one.
Oh, this dude, he's all over the place. This one?
Yeah.
There he is. Alright. Oh, alright, so what did they graph? Did they graph that side of the inequality? What did they graph? What's the difference between the function on that side and what they actually graphed? What was the first thing they did? Subtracted 6x squared, right? So what does the inequality look like if they do that? X to the 4th plus x cubed minus 6x squared is bigger than or equal to?
0.
0. Kick ass. So visually, do you see how they didn't give me like a 3-line like the last problem did? They don't have to because the line's there. Where's the line that I'm comparing this to then? 0. Where's that? Yes, the x-axis. So this is asking you, when are the outputs for this function bigger than 0? When is it positive? So when is it negative? All this stuff here, right? So when is it positive? Yeah, so from negative infinity up to negative 3. Always put the smaller one first when you do interval notation. Negative infinity up to negative 3. Where else is it positive? 2 to infinity. And so if I do that, if I say negative infinity to negative 3, or 2 to infinity, I'm not quite right.
Negative 3 included.
Yeah, so let me make sure everybody's up with this. So below here, it's positive. So all that's in there. Because the question is, when is it positive? Or 0, so that's going to be the next part of our problem. And then what did I do wrong?
Negative 3 included and 2 included.
Thank you. And the only thing we left out is one more place that equals 0. That's 0. So I have to say or squiggly 0. Squiggly because there's a finite number of things in here. In fact, there's only one. Whereas there's an infinite number of things in there. That's why I used interval notation for those. I like it. To do this by hand, now just stay with me for a second. If I wanted to do this by hand, I would start to factor this. So let's check this by hand. How would you factor this? Take out x squared. And how do you factor this? So that would be negative 3, 2, 0. Right? Now I'm in my zeros. I can make my little number line. Do you guys understand? So the graphical way of doing it is just another option. And the graphical way is kind of nice because I can very quickly, anything down here is negative, anything up there is positive. Bam. Right? That's the point. If I graph it, then it's a little quicker. How long would it take you to graph this by hand? And you figure, well. So that's why we developed this way of doing it by hand algebraically. So I don't have to graph it first. You got to try it out to see if you're with me or not.
I'm reading it to 10-1-30.
10-1, number 30.
Don't forget about 45.
Which one? Sorry?
That's about 45.
9.4, 45.
Yeah.
Oh yeah, let's do that next. And then we'll do this one. Turn this guy on so we can warm up. So 9-4, number 45?
Yep.
What I love about, if there is a word problem type that you should not be as freaked out about, it's the system of equations word problem types. Because they set themselves up in a way. So number 45, Gene charges $20 for private tap lesson, $12 for group class. One Wednesday, Gene earned $216 from 14 students. Okay, so you see how there's two main ideas. There are two ideas because there's two unknowns. What are my unknowns? The number of students that are there for private and the number of students there for group class, right? Okay, cool. I like it. Since there's two unknowns, they have to give me two pieces of information. Like I told you before, we are going to work our way into systems of three variables. Oh shit. Right? X, Y, Z. I've been talking about planes. Remember that day when you're all like, he's pointed at the corner of the room for some damn reason. Planes and where they intersect. That's going to be three variables. If I have three things I don't know, they must give me three pieces of information. Does that make sense? So in these, if I have two things I don't know, they got to give me two. There's money, and there's number of people. So there should be a number of people equation, and there should be a money equation. So what are my two things I don't know again? Yeah, the number private and the number group. So remarkably enough, I'm going to suggest that we call the number of private P and the number of group G. So this is a nice movie you can take everybody to. So let's talk about, there's almost always an easy equation. It's called the total equation. The total number of students is 14. And how do I get that in from an equation? The number of students who are in the private, P. Oh yeah, so you almost always have A plus B is 20. C plus F is 38. You always have what I call a total equation. This is the total of all your unknowns.
I include the money for this week.
Now you talk about the money. So how many private students did you have? P. Each one of them had to pay how much? 20 bucks. Of course, it's private, man. You got to pay more. So how much money did you make total from those students? $20 per each private student, right? 20 times P. Does that make sense? If she had 4 private students, she would have made 4 times 20, 80 bucks. Okay, maybe. And of course 12 for the group class. So what do I do there? So you see how this is money? 20 per person times people is money. 12 per person times people is money. So they better equal money. 216, 11. So 11, when people do this, I don't know how she makes it. It's not a good day for her. So 216 is a little better. So make sure that money plus money is money, people plus people is people. Right? The equations actually have to make physical sense, believe it or not. Math is not devoid from reality. Math lives in reality, no matter what you think. And now you solve this however you want to.
Elimination.
You can do elimination, you can do substitution. I don't care. So if you want to use elimination, what would you do?
Negative 12.
Sure. And if you notice, the first thing I would do is maybe reduce those, but it doesn't really matter. Right? You multiply that by negative 12. So you get negative 12p minus 12g equals whatever 12 times 14 is. I can't even think. 168, yeah. That's a g. Negative. So then this is 8p equals 48, good. I'm almost stalling. I'm going to stop right there. I'll let you. Is that cool? Whoever asked that question, it's almost done. So it's got to be cool. Do you guys understand the point I'm trying to make about these problems? These word problems are actually normally easier than your classic word problems. You're leaving Denver going 50 miles an hour. You're allowed to tear your hair out a little bit of that one. These, not nearly as weird, believe it or not. They're a little easier to set up. Yeah.
Where'd you get the 12p from? Or the negative 12p?
Multiply this by negative 12 so that these will kill each other.
Oh, okay.
Yeah, so multiply all these by negative 12 and then add them together.
Thank you.
That's elimination. You could solve, you could subtract p, solve for g, plug it in, you can substitute. I don't care. Either way.
Number of people.
Yeah, my G's and my 6s, so G was maybe not the best letter to use. That still looks like a 6 too bad. All right, you guys with me? Any more questions on that one? Okay, so let's look back at number 30 finally. I want to show you this, and I assigned this just so I would remember I wanted to show this to you. Oh, where was it? Where was that? 9-4?
10-1,
10-1?
number 30.
Oh, yeah, okay. Unfreeze. All right, this is kind of nifty. Now, first thing to notice is, can somebody tell me, you can read it right off of there, but what does a variable mean? What is x?
Any number.
Number of years after 2000, right? So this is not really 2000, this would really be 0, because it's 0 years after 2000. This would be 1, and so forth. Is that cool? So I'm going to show this to you. You have no reason to do this, except for this problem, right? I want you to know this exists. It's kind of nice, because you guys are supposed to have a TI calculator. Many of you need it for the next level anyway, too. Those of you going into statistics, how many of you guys are taking statistics eventually? You're going to be doing exactly this. This is called a correlation study. Well, it's not exactly this this year, but I can correlate two things together, like the age when you're potty trained versus how many times you go to jail later in life, stuff like that. All right? And see, there's a correlation between the two. If you play basketball versus your height, stuff like that. So let me pull up the calculator here. And what we're going to do is we're going to input these as x values. We're going to input these as y values. This is a graphing calculator that costs around $100. It should be able to eat these up and spit out a line that sort of fits this data. So, for example, if I had if I plotted time of morning up till like 1 o'clock and the temperature, I might get something like this. You with me? Maybe the temperature will increase sort of straight. And then if I draw in there like a line that tries to average out those points, that's what's called the best fit line. That's going to be the straight line that best fits that data. So the points are not exactly on that line, but the line is kind of like an average of where those points are. So if I wanted to estimate at 10 a.m. what was the temperature, I can just plug it into the equation of that line and tell you. That's my best prediction for what the temperature was. So if I plug these in, let me show you where these are. Oh, I'm doing that. Let me not trip over and kill myself. All right, let me just show you this once here. Go ahead. So if you go to stat, and to be honest, just show you, well, just to remind you guys, anytime they have reference to graphing calculator procedures, there's an example that does exactly what we're about to do on page 620. They tell you exactly what buttons to press and so forth. So if you hit stat, which is kind of like what I said, it's from statistics analysis, and hit edit, then I can put in there these points. So this is just like an XY table. It's kind of like a third thing here if I want a third variable. But there's my 0 for 2000, 1 for 2001, so forth. On the other. Good. 2004, 2005, and then 2006 we just were asleep the whole year, so we missed that. L2 is going to be these percentages. 31.4% of teenagers smoked back in 2000, and so forth. Okay. 0.20. All right. So, and again, they explain to you the procedures for how to do this. And I just want you to realize that your calculator can do this. And I'll show you a simpler example here in a second. But if you go to stat plot, normally I hit y equals if I want to graph a normal line. But now I want to graph this statistics stuff. I just put under stats. I want to go up here to stat plot. And I want to turn this plot on. And I want to plot a bunch of points. So there it is right there. I want to plot all these points. My x's are in L1, my y's are in L2. And again, this is not stats class. So the reason I assign this is because they give you the procedure in the book. And I just want you to realize that straight lines do exist in real world. And our calculator should be able to come up with them. It costs enough money for this thing. So now watch, this is kind of cool. If I graph right now, I don't see shit. So that's kind of anticlimactic. But if I hit zoom, oh, I'm sorry, you guys with me?
No.
So after you turn on the plot, you
Turn it on. Make sure you got the little points. See the little points, that one? Make sure that one's highlighted. L1 is the x's, L2 is the y's.
Yeah.
And then what I always talk about is you could be a square, you could be positive, you could be a little speck of dust in the universe. I teach math, so I'm a square.
The plot.
Hover over the word on and then hit enter. Make sure on is highlighted. What happened? So you would think if you go to second, y equals, get here, are you here? Cool. Hit enter. Now hit enter when you're on. Good. Alright, I don't want to waste too much time on this. Hit zoom 6. I mean, not 6. I'm so used to 6. Zoom, there it is, 9. Zoom stat. It'll zoom in on my statistics. And you see, there's the points we just plugged in. So the point they're trying to make is the percentage of teenagers who have smoked has gone down since the year 2000. But now what I can do is I can get a line that best fits that data. Is that perfect straight line? Hell no. But there is a line you can imagine drawing that would be sort of like a visual average of where those dots are. So the way to do that is it kind of gives it away. So if you hit stat again, edit is where you put stuff in. Calculate, calc is where I calculate stuff. Which one of these do you think is going to give me a straight line? Kind of gives it away. Number 4, because it's ax plus b. Of course, statistics, statisticians have to be different than math people. They say, that's nice if you're m, we're going to call it a, you know, whatever. So, number 4, enter, and then it gives me the line. The slope is this, and the y-intercept is this. Not a pretty line, but that's the equation of the line.
What happens when it says dimension mismatch?
When you do your stat edit, make sure that there's nothing. Mismatch means your dimensions don't match. One list is longer than the other, and that's going to freak it out because it's missing a coordinate then. Yeah. All right. So real quick, let me show you a simpler example. Just watch. If I clear that out, and I clear that out. And this is a question I might ask you on the test. So take a second and try this question out, and then I'll show you. I'll have the calculator do it for me. Can you guys find the equation of the line that goes through 1, 5, and -2, -1? You find the equation of the line that goes through those 2 points. That is a type of question I can completely ask you on the test tomorrow.
Don't you use the slope formula? Slope formula.
Cool, exactly. What's up? Let's see. So the slope would be,
-1 is 5. -5.
so the slope would be 5 minus -1 over 1 minus -2. Is that cool? y2 minus y1, x2 minus x1. Okay. So then I get 6 over 3, I get 2. I get slope of 2. And now you can use either mx plus b, or you can use the other guy. Yeah, y minus equals m times x minus x1. Or you could use y equals mx plus b. Believe it or not, now some of you guys might not realize you could use this, because what's b? No. Don't, you can't tell me what it is. What is it in general? Y-intercept. Do I know the y-intercept? I don't have a clue what the y-intercept is. Right? But you could actually still use this. Maybe I'll show you in a minute. But if I use this guy makes more sense because I have a point and I have the slope. So I got y minus the y piece. So which point do you want to use? It doesn't really matter. Sure. So y minus the y piece. Y minus 5 equals the slope 2 times x minus the x piece. So you get y minus 5, 2x minus 2. I get y equals 2x plus 3. And how do you check yourself? Real quick. If you plug in a -2, what are you supposed to get out? -1. So when you plug in -2, twice -2 is -4, plus 3, -1. So that's a quick way to check yourself. Real quick, just to show you in case you've never seen this, I could use this. I pick either, let's use the same point. So y is 5 when x is 1. Now solve for b. -2 minus 2, b is 3. Bam, right?
So that's the answer, is y equals 2x plus 3?
Yep, that's the equation of the line for this. You with me so far?
Yes, sir.
That should sound very familiar. Now, let's make this guy do it for us. Now we've already done it, but so we got 1 point would be 1, go in there, 1, 5, and the other point was -2, -1. Yeah, you hit stat, edit, and then if you have stuff in your list, you can just clear. I don't want to clear it, Jeff. Okay, you can just clear it out of the list. Don't delete it or the list just goes away. That's bad. So now if I do stat, calc, number 4, it's going to tell me my slope is 2, my y-intercept is 3, right? That's what we got. We got a slope of 2 and a y-intercept of 3.
How did you get there? Put
Stat,
count.
edit. Oh, I'm sorry, you already got the data in? Go to calc and then number 4. Yep. And then it will tell you the slope and the y-intercept for your line.
So the answer to 30 would be y equals something x plus y or z.
30, was that the one that was in there before?
Yeah.
Yeah, and what was it actually asking for? Let's see. What section was that again?
1.1.
There we go. Yeah, it just said find a linear function, so it'll be y equals whatever. Yeah. Cool. All right. Now I love it. I know I got myself in trouble for assigning those. I wanted to assign them because I want to show you a few of the things that the graphing calculator can do. And those of you that want to take statistics or need to, you're a little bit ahead of the game. You're going to be using the hell, obviously, out of that stat button. Kind of makes sense because you'll be in stats class. But I just want to show you what the graphic calculator is able to do. It's also able to do, that's linear regression. It can also do quadratic regression. Right? It could fit a parabola to something. So that would be something in real life that would be parabolic, would be energy use in your home. When do you think the energy use is going to be biggest? When it's really, really hot and when it's really, really cold. And in the middle, it's going to be down here, right? So that would be parabolic. So very often energy use is parabolic because there's normally two extremes during the year. Are you with me? Of course, if you live in San Diego, they're not really what you would call extremes in other parts of the country. Now, you live in El Cajon, you get a little more extreme. Yeah. Okay. You guys want to take a little break? All right, let's do this. Let's take a break. How long of a break do you need? An hour? Maybe not the greatest. Remember, break is nice, but you also want to kind of leave at some point and go somewhere else entirely. So maybe come back at 1:45. Cool. I'll go upload this.